Hello, I am Mrs. Nuzhat Parveen Gunwan, Associate Professor in Mathematics in CCAP's ARS Side Degree College for Women, Vijaypur. Today we shall be discussing limit. Limit of not any function but specially the functions which are reducing to 0 by 0 form or infinity by infinity form or 0 raised to 0, infinity raised to 0, 1 raised to infinity, infinity minus infinity. All such forms are called indeterminate forms which cannot be obtained easily. So there is a rule to find limit of such functions. For example, 0 by 0. Say we are finding limit of fx by gx as x tends to some number a. If f of x becomes 0 and g of x becomes 0 at x equal to a. If f of a is 0, g of a is 0, then this becomes 0 by 0 form, which is undefined, whose value cannot be determined. So limit of such functions we will try. Initially we shall find only 0 by 0 form limit, and then that can be applied to infinity minus infinity, 1 raised to infinity, infinity raised to 0, all such indeterminate forms. Only one rule called L'Hospital's rule will be applied to all such forms, which will be initially reduced to 0 by 0, and then the same method, L'Hospital's rule, is applied. Now what is L'Hospital's rule? If we are finding, say for example, limit of fx by gx as x tends to a, if it is becoming 0 by 0, then this limit of fx by gx as x tends to some a will be equal to limit of f dash of x by g dash of x as x tends to same limit a. This rule is called L'Hospital's rule. Now this is possible only if f dash of x and g dash of x are also not equal to 0 at x equal to a. This rule can be applied only if f dash of x not equal to 0, g dash of x not equal to 0. If this is also 0, then repeatedly L'Hospital's rule will be applied. That means instead of limit of f dash x by g dash x, we shall be finding limit of f double dash of x by g double dash of x as x tends to a, and this will be continued. Now this rule is called L'Hospital's rule because some mathematician by name L'Hospital, he introduced this, so we call this as L'Hospital's rule. Let me consider a problem. Limit of 1 plus x raised to n minus 1 divided by x as x tends to 0. Now if we directly substitute the value of x to be equal to 0, we get 1 plus 0 raised to n means 1 raised to n, that is 1, minus 1 minus 1 means 0, and divided by x equal to 0, that means 0. So this kind of expression is undefined. It is called indeterminate form. So now we will be applying L'Hospital's rule to this. It states that we have to differentiate numerator independently, denominator independently with respect to x. So this is equal to limit as x tends to 0 of derivative of this will be n 1 plus x raised to n minus 1 minus derivative of 1 is 0 divided by derivative of x is 1. Now in this part we will substitute x equal to 0. It will be n into 1 plus 0, that is n raised to n minus 1, 1 raised to n minus 1 is 1 only. So it is simply n minus 0, that means n only, divided by 1, which is n. So this is limit of this function. Let me consider another example. Limit of x e raised to x minus log of 1 plus x divided by x square as x tends to 0. Now if we see x equal to 0, if we substitute x equal to 0 in the function, what happens? 0 into e raised to 0 minus log of 1 plus 0. That means it will be 0 into any number is 0 minus log of 1, which is also 0, divided by x equal to 0. That means this is 0 by 0 form. So now we can apply L'Hospital's rule to this. That means we have to differentiate numerator and denominator independently with respect to x and then substitute the limit x equal to 0. So this is equal to, I am differentiating this, which is uv form, x e raised to x, derivative of e raised to x is e raised to x, plus e raised to x, derivative of x is 1, minus derivative of log of 1 plus x is 1 upon 1 plus x. This is derivative of numerator. Now derivative of denominator, which is 2x. Now we shall check numerator and denominator at x equal to 0. What is value of numerator and denominator at x equal to 0? Now if we put x equal to 0, it will be 0 into e raised to 0 is 1, plus e raised to 0 is 1, minus 1 upon 1 plus 0 is 1, that is 0 again, and denominator 2 into 0 is 0. So again it is in the form 0 by 0. Therefore we have to apply L'Hospital's rule repeatedly. Limit as x tends to 0 of x e raised to x plus e raised to x into 1. It is uv form, x fixed, derivative of e raised to x is e raised to x, plus e raised to x fixed, derivative of x is 1, plus of derivative of e raised to x is e raised to x, minus derivative of 1 upon 1 plus x will be minus 1 upon 1 plus x bracket square. So minus of minus, it will be plus 1 upon 1 plus x bracket square. This is the derivative of numerator. By denominator's derivative 2 into 1. So this is L'Hospital's rule applied to this form in second hand. Now let us check x equal to, by putting x equal to 0 in this expression, it will be 0 e raised to 0 1, that means 0 into 1 is 0, plus e raised to 0 is 1, e raised to 0 is again 1, it is 1 upon 1 plus 0 is also 1, 1 plus 1 plus 1 divided by 2, it will be 1 plus 1 plus 1 divided by 2, that is 3 by 2. This is limit of this function as x tends to 0. This is the problem based upon 0 by 0 form. Next, let us check another form like infinity by infinity. If we have limit of fx by gx, say we have limit of fx by gx as x tends to some value a, it is reducing to infinity by infinity form. If it is infinity by infinity, then actually this is infinity means 1 upon 0, and this infinity also 1 upon 0 like. If we simplify this goes to numerator, this will be 0 by 0 form. This will be reduced, infinity by infinity will be reduced to 0 by 0 form. That means we can apply the same L'Hospital's rule to infinity by infinity form also. So let us consider one problem on infinity by infinity form. I'll take example log of tan x by log x. We shall be finding its limit as x tends to 0. We shall be finding limit of this as x tends to 0. Say I am denoting this limit by L. L is equal to, I shall consider limit as x tends to 0 of log of tan x by log x. Now if we substitute x equal to 0, tan 0 is 0, log of 0 is minus infinity, and log of 0 is minus infinity. Therefore it is infinity by infinity form, and hence we can apply L'Hospital's rule. So this is equal to limit as x tends to 0 of derivative of the numerator independently. Derivative of log is 1 upon, that means 1 upon tan x, into tan x derivative is secant square x, derivative of numerator is over, and derivative of denominator is 1 upon x. Now this is equal to limit as x tends to 0 of, let me simplify this a little, we have this x coming to numerator, it is in the denominator of denominator, so here comes x in the numerator, and here we have tan x in the denominator of numerator, into secant square x. Now let us check what is the value of this, whether it is well defined or we cannot find, is it indeterminate form or what. If it is indeterminate, we apply L'Hospital rule repeatedly. So this is equal to limit of x by tan x. We know it is very well known form, its value is 1, and sec of 0 is also 1. So directly we shall substitute, without going to L'Hospital's rule, we shall substitute the value of this 1 into sec 0 is 1, hence limit of this is equal to 1. Hence we can find the limit of indeterminate form by applying L'Hospital's rule. Similarly, various problems can be solved by L'Hospital's rule. Say another example I'll take, limit of tan of 5x by tan x as x tends to pi by 2. See, so far we consider x tending to 0, x tending to 0, but x can tend to any real number, maybe any pi by 2 or 1, 2, 3, 4 real number, positive, negative, any number. Particularly here we have taken x, a problem where x is tending to pi by 2. Now if we substitute x equal to pi by 2, what happens? Tan 5 pi by 2 divided by tan pi by 2. We know this is tan pi by 2 or odd multiple of pi by 2, or tan operating upon odd multiple of pi by 2 is infinity, and tan pi by 2 is also infinity. So this is infinity by infinity form. Therefore we have to apply L'Hospital's rule. Let us apply L'Hospital's rule. Say I am denoting this by L, this limit. So limit as x tends to pi by 2 of L'Hospital's rule means we have to differentiate numerator and denominator independently with respect to x. Derivative of tan x, it is secant square 5x actually, secant square 5x, and derivative of 5x is 5 divided by derivative of tan x is secant square x into 1. As multiple of x is 1, here it comes 1, here multiple of x is 5, so it comes 5. Now if you put x equal to pi by 2, what happens? Sec square 5 pi by 2, odd multiple of pi by 2, cos pi by 2 is 0, Sin pi by 2 is 1. Sec pi by 2 also, sec pi by 2 will be infinity. Odd multiple of pi by 2 is infinity and sec pi by 2 is infinity. Therefore, it will be infinity by infinity form. Hence, we cannot find as it is the limit of such function. Therefore, we have to apply L'Hospital's rule as x tends to pi by 2. Now, derivative of secant square 5x will be 2 sec 5x into sec x derivative is sec x tan x. As it is 5x, so one more sec comes here, secant square x into tan x. But here as it is 5x, so secant square 5x into tan 5x into 5x derivative 5, and already 1 5 we have here, divided by its derivative of secant square. It will be 2 sec x into sec x derivative sec x tan x, that means sec square x tan x into 1 here, because here multiple of x is 1. Now if we put x equal to pi by 2, it will be infinity by infinity again. So let us convert all the terms into sine and cos. So limit of 2 cancels. Let me convert secant square into cos. 1 upon cos square 5x divided by, this will be 1 upon cos square x, and tan x derivative is, tan x value is sin x by cos x, as it is tan 5x, so it will be sin 5x by cos 5x divided by tan x is sin x by cos x. 5 5's are, it will be 25. So x tending to pi by 2. Now tan cos 5x, 1 cos 5x cancels, and cos square x cos x, 1 cos cancels. So here remains as x tends to pi by 2 of sin 5x by cos 5x, sin 5x by cos 5x divided by 1 cos cancels, there remains cos x, sin x by cos x, that is, and into 25. Now sin x upon cos x is tan x, so this will be limit as x tends to pi by 2 of, this is tan 5x divided by tan x into 25. Now still it is infinity by infinity form. Therefore what we do is we divide and multiply here by suitable number. Tan theta by theta, as theta tends to 0 is 1, we know this result, so we will try to apply this result here. It is this is equal to limit as x tends to pi by 2 of tan 5x divided by, actually it is tan x. I require here 5x, so I shall multiply also by 5x. Tan 5x by 5x, its limit will be 1. So I am making some adjustment. I am multiplying, dividing by 5x. Here we require x, so I shall multiply and divide by x, so that its limit is 1 and its limit is 1, and here x cancels, there remains 5, and together with this we have 25. Therefore this is equal to, I shall substitute this is equal to 1 into this x cancels. Here comes 5 into 25 divided by this is 1 into this is cancelled. Therefore altogether 25 5s are 125. This way we have various indeterminate forms. We can consider other examples too for infinity by infinity form. Let me take another form like infinity minus infinity. Limit of infinity minus infinity form as x tends to any value, say a. If any function reduces to this form, then we have to find its limit by using L'Hospital's rule. Let's see how it is to be applied. I am considering one problem. Say limit as x tends to pi by 2 of sec x minus tan x. Now cos pi by 2 is 0, so sec pi by 2 is infinity, minus tan pi by 2, as we know it is infinity. So this is infinity minus infinity form, so which is indeterminate. Therefore we reduce this to either 0 by 0 or infinity by infinity form, so that we can apply L'Hospital's rule. So this is equal to, I write this as x tending to pi by 2 of sec x, I write 1 upon cos x, minus tan x, I write sin x by cos x. So this is equal to limit as x tends to pi by 2. Till we substitute limit, we continue writing limit as x tends to, as x tends to, and so on. Therefore it becomes cos x, and LCM is cos x, so numerator will be 1 minus sin x. Now if we put x equal to pi by 2, it will be 1 minus sin pi by 2 is 1, 1 minus 1 0, and cos pi by 2 is 0. So now it is 0 by 0 form. Therefore we can apply L'Hospital's rule. So let us apply the rule. It will be limit as x tends to pi by 2 of derivative of numerator. Derivative of 1 is 0, minus derivative of sin x is cos x, and derivative of cos x is minus sin x. This is equal to, this minus minus becomes plus, cos pi by 2 is 0 and sin pi by 2 is 1. It is well defined. So 0 by 1 is 0, hence this is the result. This way any infinity minus infinity form can be reduced to either 0 by 0 or infinity by infinity form, where we can apply L'Hospital's rule. This is infinity minus infinity type of problems. Now let me consider 0 raised to 0 form, where this also can be reduced to infinity by infinity or 0 by 0 form. For example, I'll take one problem. Limit of cos x raised to pi by 2 minus x as x tends to pi by 2. Now if you put x equal to pi by 2, what happens? Cos pi by 2, which is 0, and pi by 2 minus pi by 2, it is 0. 0 raised to 0 form it is. It is 0 raised to 0 form, where we cannot apply L'Hospital's rule directly. Therefore let me take this as L, limit of cos x raised to pi by 2 minus x as x tends to pi by 2. Now what I do is I'll take log on both the sides. Log of L is equal to limit as x tends to pi by 2 of log of this value, log of cos x raised to pi by 2 minus x. So this is equal to limit as x tends to pi by 2 of this power becomes a multiple as log of x raised to n. For example, log of x raised to n is n log x. Therefore this rule I apply here. Hence we get pi by 2 minus x into log of cos x. Pi by 2 minus x into log of cos x. So which form it is? X tending to pi by 2. Pi by 2 minus pi by 2, 0. And log of cos pi by 2 is 0. Log of 0 is infinity. 0 into infinity. This is 0 into infinity. As it is, we cannot apply L'Hospital's rule. So it is to be reduced either 0 by 0 or infinity by infinity form. This cannot be brought to denominator. It will be easy to bring this to denominator. Therefore, this is equal to, I take limit as x tends to pi by 2 of log of cos x. I keep in the numerator itself, but denominator I write 1 upon pi by 2 minus x. Now if you put x equal to pi by 2, log of cos pi by 2 is cos 90 is 0, which is infinity, and pi by 2 minus pi by 2, it is 0. 1 upon 0 is infinity. So this is infinity by infinity form. Hence we can apply L'Hospital's rule to this form. Limit as x tends to pi by 2 of derivative of numerator 1 upon cos x. Derivative of log cos x is 1 upon cos x into derivative of cos x is minus sin x divided by. We differentiate numerator and denominator not by using u by v form. We differentiate numerator and denominator independently. So its derivative 1 upon x derivative, like this is like 1 upon x derivative. So it will be minus 1 upon x square. That means pi by 2 minus x its square, and its derivative with respect to x is minus 1. This minus of minus, it will be plus, and then there is minus sign. So altogether it is limit x tending to pi by 2 of, this is tan x divided by, it is 1 upon pi by 2 minus x its square. Now as x tends to pi by 2, tan pi by 2 is infinity. Pi by 2 minus pi by 2, it is 0. So tan x divided by pi by 2 minus x square, it will be infinity by infinity form. Hence we apply again L'Hospital's rule. So this is equal to limit as x tends to pi by 2 of tan x divided by, I'll take 1 upon pi by 2 minus x, one part of this square I'll take here, and into 1 upon pi by 2 minus x. So this way I separate this function into two parts so that I can apply our L'Hospital's rule easily. But here you see, this is tan x tending to pi by 2, then if x is tending to pi by 2, then if we take pi by 2 minus x as say y, then pi by 2 minus x will be, pi by 2 minus x will be